Hello friends, grab your coffee, grab your cookie, and today please keep both far away from any coal-fired boiler or asphalt drum because we are talking about a filter material that lives right inside combustion exhaust, PPS filter media, also known as polyphenylene sulfide. You may know it by brand names like Ryton or Procon, but in the dust collection world, PPS is famous for one thing: surviving hot, acidic gas streams. I am Michael Klepik, and for more than 15 years I have been designing dust collectors for power plants, incinerators, cement mills, asphalt plants, and oil and gas firing systems. Today I want to explain where PPS shines and where it absolutely does not. What PPS filter media really is. PPS filter media is a synthetic needle felt fabric engineered for thermal and chemical stability in combustion environments. Technically, first, normal maximum continuous operating temperature is 375 degrees Fahrenheit. Second, the fiber has excellent resistance to acidic gases. Third, it performs well in sulfur-containing exhaust streams. Fourth, it maintains dimensional stability under heat. Fifth, it is widely used in fossil fuel and waste combustion systems. PPS is not about extreme heat alone, it is about surviving hot chemistry. Where PPS filter bags are used, PPS is commonly specified in combustion-related industries. First, coal-fired boilers and utility plants. Second, incinerators and waste-to-energy systems. Third, fluidized bed combustion systems. Fourth, cement mills and kiln exhaust systems. Fifth, asphalt plants and drum mixers. Sixth, oil and gas firing systems. Seventh, pulverized coal injection systems. Anywhere hot gas, sulfur, and fine particulate come together, PPS often becomes the first choice. Why PPS performs so well in combustion exhaust? PPS has several key advantages. First, excellent resistance to acid attack from sulfur oxides. Second, stable performance in fluctuating combustion conditions. Third, good mechanical strength at elevated temperatures. Fourth, compatibility with continuous pulse jet cleaning. Fifth, reliable service life in power and energy applications. This makes PPS a true combustion specialist filter media. Temperature and chemical limitations. PPS is strong, but not universal. Its limits include: first, maximum continuous temperature is 375 degrees Fahrenheit. Second, PPS degrades rapidly in oxidizing environments. Third, high oxygen content combined with high temperature shortens filter life. Fourth, nitrogen dioxide and strong oxidizers attack the fiber. Fifth, PPS is not suitable for very high temperature kiln zones. If oxidation dominates the chemistry, P84 or fiberglass may be the better choice. Behavior of PPS in airflow and filtration. Inside a dust collector. First, PPS forms a stable dust cake quickly. Second, pressure drop remains predictable over time. Third, pulse jet cleaning works efficiently. Fourth, the fabric resists acid condensation damage. Fifth, filtration efficiency improves rapidly after startup. This predictability makes PPS popular in large continuous duty plants. Which torch air systems use PPS media? Torch Air installs PPS filter bags in several combustion duty systems. Blizzard Combustion Series BagHouse designed for coal-fired boilers, incinerators, and cement mills. Blizzard Asphalt Plant Edition built for sulfur-containing exhaust and hot aggregate dust. Blizzard Energy Series used in fluidized bed systems and oil and gas firing units. Custom power and process collectors engineered specifically for high-temperature, acidic exhaust streams. PPS is chosen when combustion chemistry defines the challenge. OSHA and NFPA compliance PPS filter media supports compliance with: first, OSHA particulate exposure limits in power generation and combustion plants. Second, emission standards for coal, waste, and asphalt industries. Third, NFPA guidelines for dust handling in thermal processes. Fourth, environmental regulations for sulfur-containing exhaust. Fifth, continuous duty industrial ventilation requirements. Correct chemical compatibility is essential for compliance and safety. Dust collector system design considerations. When I design a dust collection system around PPS filter media, I focus on combustion chemistry control. First, differential pressure sensors rated for elevated temperatures. Second, careful control of oxygen concentration in the gas stream. Third, stable pulse jet cleaning to avoid thermal shock. Fourth, insulated housings to prevent acid condensation. Fifth, automatic hopper discharge for fine combustion ash. Sixth, corrosion-resistant ductwork and hoppers. Seventh, gas chemistry monitoring to detect oxidizing conditions early. This allows PPS filters to deliver long, predictable service life. PPS filter media is the right solution for hot, acidic, combustion-driven exhaust systems. With a normal, continuous operating temperature of 375 degrees Fahrenheit and excellent resistance to sulfur-based acids, it has become a standard choice for coal-fired boilers, incinerators, cement mills, asphalt plants, and energy systems. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, when combustion creates the problem, the filter media must be built for fire and chemistry. See you in the next video.